Welcome. In this module, we are going to take a deeper look at BigQuery, which is a data warehouse on the cloud provided by the Google Cloud Platform. So, we are going to cover a quick review of the OLAP and OLTP database systems that we have looked at, and then we'll take an intro into BigQuery. So, let's get started. Let's quickly review the difference between an online transaction processing systems OLTP versus the data warehouse OLAP system, online analytical processing system across multiple features. So, of course, first is the purpose for which they are built. OLTP are usually to control and run essential business operations, whereas OLAP is to plan and solve problems that support decision making, right? So to discover hidden insights by merging data together from multiple operational systems. How does data get updated into an OLTP? It's short, faster updates initiated by the user who uses the system. Whereas in OLAP, it is mostly periodical, as we have seen, right? So data is refreshed periodically, scheduled, and there are long-running batch jobs. With respect to data design, OLTP has a normalized database for efficiency, so data redundancy is kept to a minimal. Whereas an OLAP data system, it is a denormalized database, and you do have data redundancy because the idea is for data analytics. With regard to space requirements, OLTP is generally small if historical data is archived, whereas OLAP is generally large because it is bringing together of multiple data sources. Continuing on with regard to backup and recovery, OLAP does regular backups are required to ensure the business continuity and to meet legal and governance requirement, right? Whereas in OLAP, lost data can be reloaded from the OLTP system because they are coming from operational database which is the equivalent to your regular backup. Of course, there is also backup archiving that happens in OLAP as well of what we call the cold data, right? Data that has already not very relevant at a particular point in time. With regard to productivity, in order an OLTP system increases productivity to the end user, whereas an OLAP increases productivity to the business stakeholders, the business managers, executives, and the data analysts. The data view, OLTP lists day-to-day business transactions, whereas OLAP, as we have seen, is a multi-dimensional data view of the enterprise data. Let's get introduced to BigQuery, which is a data warehouse on the cloud provided by GCP, which is Google Cloud Platform. So this is a serverless data warehouse provided by Google, which means the end user doesn't have to manage any servers or database software installs really. Right? So the software as well as infrastructure is included in the data warehouse service, which means it's highly scalable and available. So the two main characteristics of why people tend to transform to the cloud. BigQuery in and of itself has multiple built-in features other than being a data warehouse. It also provides built on top of it are huge machine learning capabilities, geospatial analysis, inherent business intelligence, etc. So BigQuery maximizes flexibility by separating the compute engine that analyzes your data from your storage. So this is a very important thing when you're dealing with big data, right? Volume of data of terabytes, petabytes of data. You want to move the computation closer to the data rather than move the data closer to the computation, right? So that is a very important shift when you are looking at data intensive applications. So in a BigQuery, it sort of separates the compute engine that analyzes your data from the storage. So let's look at data storage in BigQuery. BigQuery stores table in columnar format. So we have already sort of seen it's one of the non-relational data formats. So column-oriented databases are particularly efficient at scanning individual column over an entire data set and have very high data compression. So a very quick refresher. So we know of the row-oriented storage, right? So typically in a disk, uh, when you are physically storing it, so the rows are grouped together. Let's say you have 10,000 rows, then in a row-oriented data set, so the rows get chunked like maybe thousands of it and get stored, whereas in a columnar database, it's the columns that get chunked, right? So a particular data drive would have, let's say, the product information in this case, whereas another data drive would have the quantity, warehouse, etc. So it is so that all of the columns are stored at the same co-location, co-located, right, in the same location. BigQuery does not support foreign keys, so this is also a concept of NoSQL databases. So it's more suitable for OLAP and data warehouse workloads than your OLTP kind of workloads. Very quickly digging into serverless computing, because BigQuery is a serverless data warehouse. It's important to understand what serverless means. So we are already aware of in cloud computing space, the as a service models consist of three main things. You have the infrastructure as a service, IaaS, platform as a service, and software as a service, right? So depending on the abstraction, so how much of it, so in the graph that you see here, you can see how much of it you have to manage in infrastructure as a service. Everything above the OS layer has to be managed by the user, whereas everything else is managed by the service provider, rather the cloud service provider. Whereas in a platform as a service, only the data and the application is managed by the user, all the rest is managed by the cloud service provider. And then in a SaaS, all of it is managed by a cloud service provider. So serverless is also a cloud computing execution model. It is the terminology is a bit of a misnomer because it's a way in order to build and run applications without the user having to think about the service. That's what it means. It doesn't mean that the application doesn't require any server, but the user doesn't have to think about the server. Servers are still used, but the company gets back-end services from serverless vendors, right? Your cloud service providers, CSPs, who charge based on the usage and not on fixed amount of bandwidth or the number of servers itself, right? So they sort of the scalability aspect is getting paid for. So there is a way to take care of that. So serverless architecture doesn't mean servers aren't used. It's just that servers doesn't have to be monitored and controlled by the user, and it's taken care of by the um, cloud service provider. Let's look at some of the features of the BigQuery data warehouse system. Firstly, BigQuery has the ability to cache the data that you get from the queries. So what happens when you cache is subsequent queries, it sort of pulls up faster, right? So you can choose to not cache as well. That's a setting that's available, but it sort of greatly enhances the response time of a query. There are multiple public data sets that are there which you can load and play with. That will be one of the activities that we'll be doing in this module as well. Another very important thing in tables in BigQuery is the concept of partitioning and cluster. So once you get familiar with BigQuery in the first lab, we'll then go on to understand partitioning and cluster more deeply. It's just a more enhanced way of storing your data so that your query results are optimized, especially when you're working with big data. One important thing you have to remember is a lot of these serverless application cost is a very key factor. You should understand how costing is done on the cloud. So BigQuery cost happens in two ways. One is on-demand pricing. So it's approximately, so this might have changed a little bit. It's approximately about 5 US dollars for 1 terabyte of data. And then you have flat pricing, which is based on the number of pre-requested slots. Right. So mostly we tend to do flat rate pricing when your data requirement is very high, above 200, 300 terabytes, right? So in our lesson, mostly you will be using only the free tier version. You have some free credits of BigQuery, so you will be using that. And we'll be using, of course, big data, but not on the really costing as much. So let's summarize the learnings. In this module, we started by reviewing the OLAP versus OLTP and got introduced to BigQuery. So now you are ready to go on to do your working with BigQuery lab. So get done with that and then you can proceed on to the subsequent videos. All right, so I'll see you in the subsequent videos. Thank you.